Welcome back, students. In this video, we're going to cover Station 3. This is Similarity. This is from the Geometry BootCamp, EOC BootCamp 2026 last week. Just trying to catch up the videos. We have tests day after tomorrow, so trying to get these last few videos in for you. So, Similarity. This was Miss Umad's station. So let's talk about a couple of things before we flip the page. All right, so two figures on the coordinate plane are similar if, so their corresponding angles are congruent. And the corresponding side lengths, they're going to be proportional. Because if they're not quite the same, if they're the same, everything will be congruent. They're similar because the angles stay the same, always, 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 always. The sides are always in proportion. You must verify this using distance and ratios. Scale factor in sides, it's new over old. So example, I don't know where they're pulling this from. We got x over 6 on one side, 10 over 5. They're saying x equals 12 would be because it'd be 5x equals 60, divide both sides by 5, and you get x equals 12. So you just match the corresponding sides. All right, first little problem here. So we got these two similar triangles. We're trying to find the value of x. All right, so for this guy, we're just going to do the corresponding sides. Now, when they give you the triangle, you just line up the letters. But here, you can tell, so orange goes with orange. That's one arc. Two arcs, that's purple, goes, so Q goes with V and T goes with Y, so that makes R and W go together. So in this case, it's going to be QR, so this side over, so this was QR, this was orange blank, so this is orange blank, that is VW. And then on the other side of this, we got QT, so orange purple is 12. Well, we'll get to that in a minute. QT. And then over here, orange purple is VY. All right, so let's fill in the numbers. So we got X was QR. And then over here, that's 2X plus 4. 2X plus 4. And on the other side, so we got QT, that's 12. And then VY is 40. And we're going to cross multiply. So we'll just do. And notice this is 12. That's going to go with both of these guys. We're going to distribute. So 40x is on one side. And so we got 12 times 2x plus 4. I'm writing this above. So 12 times 2x is 24x, and then 12 times 4 is 48. Yep, 40x, okay. So subtract the 24x from both sides. So these cancel. So we're going to write up here. So 48 equals, because this is 48 was the only thing left over here, and it equals, so 40x times 24x is 16x. Then we're going to divide both sides by 16 because we're still trying to get x by itself. So we'll clear this. We got 48 divided by 16 gives us x equals 3. Now, what did this problem ask for? It asked for the value of x, which was 3. So we plug it in there. All right, let's scooch up a little. I'll try to make these both visible, and then we'll come look at this, flip over. We have 3 pages total. All right, so if Jeremy, that's this dude, if he's 5.75 feet tall, and when the height of the flagpole, or what is the flagpole height in feet, so question mark, we'll call it X, round your answer to the nearest foot. So he makes a shadow of 8 feet. The flagpole makes the shadow of 16 plus 8 feet because it's the whole thing. Don't just cut it off here. So we're going to put our height 1 is Jeremy, that's 5.75. Height 2 is X, that's the flagpole, so we'll just call it X. All right, and then we have the base, which I guess it would have been the other way. This is the base, I guess, because it's a shadow. It goes either way, but so base 1 that goes with Jeremy, that's 8. And base 2 goes with the flag, so again that is 16 plus 8, which is 24. So now we're going to do height 1 over height 2 to base 1 over base 2. So you got 5.75 over X and 8 over 24. Yeah. So again, just going to cross, multiply. Alright, so 8x equals. So up here we're going to, well, actually it's just, I was thinking it was something else. So we got 5.75 times 24, which gives us 138. We're going to divide both sides by 8 because, because I'm trying to get x alone, and then x is 17. 17.25. Not even sure what they asked us for. Oh well, that would be the height of the flagpole, and that's what it asked for. I said nearest foot if necessary, so yeah, 16 feet. All right, so dilations on the coordinate plane. The rule, so if your scale factor k equals 2, the figure becomes, so x comma y is kx comma ky. So good rule of thumb, if it's greater than 1, if your k is greater than 1, then it gets bigger. And if k is less than 1, it gets smaller. And if k is 1, well, 1 times anything is that number, so it would stay the same. So here, it would be 2x, 2y. And then if it was half, oh, well, it's also bigger. And over here, it'd be 1/2 x, 1/2 y, and that is smaller. Oop. All right, flip it over. I'm gonna just fold this over, make it a little easier. I've already kind of started drawing a little for us. So, all right. So D prime, E prime, F prime is an image of DEF after a dilation. Because remember, pre-image is where you start, image is where you finish. So DEF is the image after the dilation from here. So this is old. This is new. All right, so from here to here, did we get bigger or smaller? We got smaller. Reduction. All right, so what is the point of the center of dilation? So E didn't move. You count it, E is 1, 2, 3, 4, 5, 6, 7, 8, 9, and then one up, 1, 2, 3. So it's point E, and that's 9, 2. Draw that E a little better. All right, scale factor. So the way we find this, so if you go up here, and you're gonna have to trust me, you know, we're going, this is 0, 0. So we go positive this way, and I'm gonna give you these coordinates. D is at 3, 3. D prime is at 7, 3. E stays the same. It was at 9, 2. F is up here at 8, 5. And I'm sorry, F prime, and then F is at 6, 9. So we got all these points, and let's see. So remember it's new over old. So in this case, this is old, so new 7 over 3. I'm sorry. Yeah, 7 over 3. And what does it end up being? This thing was saying 1/3, but it was wrong. It is, let me see. This side is 2, so 4 on one side. So square root of 17. Well, 1, 2, 3, 4, 5, 6. So the original guy was 6, and this new one is 1, 2, 6 over 2. So, but this is new over old would be 2 over 6, so it's 1/3. Scale factor is 1/3. Coordinate rule would be 1/3 x, comma 1/3 y. Angles preserved in the dilation, yes, always. Are the sides preserved in the dilation? No. Never. Sides always change when we dilate. Angles are always preserved. Angles are preserved regardless of whether we dilate or we just transform, reflect, all that other stuff. Sides change when we dilate. Both are preserved when it's just a rigid motion. Okay. So area of similar polygons. So new over old, new over old. Just like we've been doing. Now, the difference, so it's not just new over old. So for when we're doing area, it's squared. And you're going to learn in a little bit when we do volume, it's cubed. All right, so for this guy, so these two are similar. If the area of ABC, so A is 11.7 inches squared. What is the area of this guy? So area is question mark. So area 1 is 11.7. Area 2 is X because we're looking for it. And then we have these sides. So ABC, ABC, DE. So your side 1, or base, because this is the base, but either way, 6. Base 1. Base 2 is 10. So we do, first we do our, so it's side 1 over side 2 squared. Wait a minute. Okay, yeah, and it'll also be, so area 1 over area 2 times well, okay, yeah, hold on. It'll be the scale factor. So scale factor is going to be S1 over S2, but we have to square them. So that would be 36. So 6 times 6, or 6 squared is 36. 10 times 10, 100. Area 1 is 11.7. Area 2 is X. So let's now quickly cross multiply. And then alright, so 36x, because that's this guy. And then 11.7 times 100 is 1170. Now we got to divide both sides by 36 to give us x. All right, we get 32 and a half. All right, so yeah, so the area for this one was 11.7. This one's 32 and a half because it's that's how it works out. Okay, flipping down here, we got trapezoids. We're going to find the scale factor and find the value of x. So scale factors, k is new over old. So new over old. So we have the 6 here. We don't know what this is yet, so we're going to wait. We're going to take area 1. That's 50. That's this guy. Because that's the old. That's the new 72. Now we'll take area 1 over area 2. Put it equal to side 1. Side 2. Now remember, these are going to be squared because for area, yeah, for area is squared. So let's bring this down. Area 1, let me just. So area 1 is 50. Area 2 is 72. S1. Side 1 is, so x squared, because it's these two squared, and then 6 is on the bottom. 6 squared, 6 times 6 is 36. Now we're going to cross multiply. So, just trying to help us remember as much as I can. Alright, so over here to the side we got 72. X squared is going to equal, so we got 50 times 36. So that's 1800 divided by 72. Oh, that's a nice looking number. So x squared is 25. We take the square root. Remember, it's right below 10. Boom. X equals 5. Alright, so the scale factor now, we got to go up here. Scale factor is, so this guy was 5. So it's 6 over 5 squared. 6 squared, or 6 times 6 is 36. 5 times 5 is 25. So k equals this guy. And then x equals this guy. Alright, flip it over. Trying to hurry. I'm doing okay. Not a very long video. Just tired folks. I like to get one more. But it's almost 9 o'clock, so we're gonna see what happens. So flipping over, page 10. Station 3. Sorry, I'm been all over the place. All right, so volume of similar solids. So yeah, I think it says height. Everything's squared here. So for scale factor, volume, it's new over old cubed. So all right, so and they messed up here. They're supposed to ask you for the smaller, because you'll find the larger and then use the scale factor to find the smaller. And then we got this guy down here. This, I think this one is the same as something else. I may have gotten it confused with the other. It's all right, we'll work it. So looking for the smaller one. So let's get the volume of the larger one. Volume of the larger guy is the base area times height. So the base for these guys is your length times your width, and then times your height, because length times width is your base area. So this is just going to be 14 times 7 times 3.5. We multiply those all together and we get 343. So that is the volume of the big guy. That's volume. If we're going from here to here, this will be new over old. All right, so Alright, so volume 1 is 343. Volume 2 is unknown. We're going to find that. And let's see, right, one other thing. So we got heights. The height over here was 3.5, right? Yeah. Height 1's 3.5. Height 2 is 2. So it looks like it's going from this, so new to old. This is going to be smaller. So, ow, 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 ow. So let's get our scale factor. It's going to be new over old, so 2. Where did I get? Oh, I'm looking at the wrong thing. So yeah, 3.5 over 2. But where did we get? Oh, okay. But so the first side, let's just hang on before I confuse myself. So we have the 343 over X on this side. Now on the other, so your scale factor is 3.5 over 2. And something about that I don't like, but I guess we're going, yeah, it's not new over old here. It's H1 to H2, volume 1 to volume 2. So if I'd have put the X, if I'd have done new over old, we'd have flipped it, and it's still going to end up with the right number, don't worry. So 3.5 cubed. So use calculator. So we got 3.5. This button cubed. So 42. That's on top, and then 2 cubed on the bottom. 2 times 2 times 2 is 8. So we cross multiply. So we got 42.875x equals 8 times 343, which is 2744. And now we're going to divide it by 42.875. So dividing by X equals 64. So this guy was, the volume was 343. This guy is 64. You see how much smaller he is. Okay, let's get this last one here. It doesn't have a number. I don't know if the last one did either. No problem. So got a cylinder. Volume of 128 cubic centimeters. So volume 1 is 128. And this guy, and height 1, that has a 6. What's the volume of similar cylinder? So what is it? It's X. And its height, so height 2 is 9. So we're just going to go new over old, X over 128. And then new over old, 9 over 6. You can line it up either way. Wait. Yeah, that's right. Okay, so we got to cube these 3. I mean these 2. So just show you. So 9, and this tells it I'm going to give you the exponent, which is to the 3rd power. So 9 cubed is 729. 6 cubed is 216. We got X over 128. So we got 216 X equals, so we got 128 times, let me make sure I don't get too far down. So 93,312, what was that? Chord. I want to make sure we're okay here before I finish up. This is almost the end of the video, so just bear with me another 10 seconds. So we cross multiplied here. That's how we got 216x here. And then 128 times 729 gave us 93,312. We do all that, and we see that this guy is 432. So this one was 128 with a height of 6. So add 3 more inches of height, and you ended up with 432. All right, that will be it for Station 3. If you have any questions, please let me know. I know we're getting down to the wire. I said I got Stations 2 and 4 left. Circles are kind of a lot, so I'm going to try to do it during class tomorrow and then leave the transformations tomorrow night. You guys check it out right before bed, and hopefully everybody passes. Good luck, and come see me after the test. Have a good night.